All right. What are we looking at here? It's the same lab that's in the background. What I did, I just opened up router 1, all right, because we did configure EIGRP, and I did the show EIGRP or show IP EIGRP topology, all right? And there are the codes, right, that you have passive, active, which is what we're going to talk about. You have update, query, reply, and reply status, all right? You can see that on the left-hand side, right by each network that the router has learned, there is a passive, and that is good. We want to see that. All right, we want to see that there are P's because that means it has converged. We know about that network. Now, where you say it has one successor, one successor, one successor, two successors. Whoa, look at that. So now we have something that we can go two different ways to the 16 network. So that means we have a feasible successor, right? That means, boom, hey, we can go either way. As you can see, you make the decision based on the lower metric. So this has a lower metric. Okay, so you can analyze by going back and forth in which direction. So we're on router 1, and it's via the 10115. The 10115 is this interface right here to get to that particular network, which is the 16 network. Okay, it will be the preferred route. All right, and the same thing goes over here with the 10120, whereas the 26844, or well, here we go, the 217, whatever. Okay, but you can see that the feasible distance will change, okay, throughout each particular network it goes to, and you can see how small this number is because it's via a connected interface. So the feasible distance will definitely be shorter because it's advertised from your neighbor router. All right, so this is the kind of things that you look at when you go into your topology table to see if you do have multiple paths that you can go to one particular network, okay? That will help you say, okay, what type of lines are there? Do I load balance? Do I tweak it and make it go this way instead of that way? So there's many things you can do, but definitely we do have feasible successors because there's two successors there, all right? And that's what the feasible distance is. It's pretty much just a little overview of it, telling you coming from the other router, hey, this is the best number to use. Okay, now that's what is being advertised anyway. All right, because you see that 268.6976 is right here. And if you were to look, I earlier did a show IP route, so I'm just going to scroll up, and this is for the 20 network. Okay, you can see that for the 20 network, you have the 268.976, which is the feasible distance, okay? And that will be the successor route, and it made it there. Even though it's showing you that it's going both ways to the 10.1120, okay? And this is where you use both tables. You look at your topology table, and you're analyzing, and you're saying, okay, this is telling me it can go two different ways, like it's telling you right here, and this one's a fast Ethernet, okay? And this is a serial, so I will bargain it will use this, right? It will use, even though they're the same, because obviously this is a lab. Okay, I'm going to minimize this real quick. So we were on that router right here. We're trying to go to the 20 network, which is where? 28, 24, 20, right here. And we're sitting up here. So this is a slower way. That's why it has a higher number. Serial, fast Ethernet, and then it gets to the router. Where here is fast Ethernet, serial, fast Ethernet. We're right here. Somewhat similar. That's why they have the same number, but we're going to change that later on when we start playing around with the interface and changing the bandwidth on certain routers, and you'll see how those numbers will then change. Okay, but let me just tap this right here, bring it back up. But this indeed is your topology table, and this is the things that you may see. But what most interests you is these two different codes. You know, it's got to be passive, and taking a look at which, because it's going to be based really on that number. Okay, if they give you a print screen, if to go to this network, which number will you choose? It's always the lowest metric. And remember, with RIP version 2, everything is based on hop counts. where an EIGRP is based on the lowest metric. Lowest hop count for RIP, lowest metric for EIGRP, lowest cost for OSPF. All right, but there you go. But again, you just can't decide on your topology table. You look at it, you analyze it, you bring up your other table, and you say, here's my routing table. These are my successor routes. What is it telling me here? And you go back and forth, or you can do a side-by-side comparison. So you can analyze, because you, as a network engineer, need to understand what is actually being connected. Are these fiber lines? Are these T1s? Are simple Cat5? Are we looking internally? What is it? How are they going across? Is it serial? And if it's a serial, is it a wide area network? Are we running wide area network protocols? If we are, what is the speed of that wide area network? Okay, so all these different things. Is it a Metro E? All these things come into play when you're looking at things and saying, okay, which way do I want them to go? And then you can tweak or load balance using the variance command, however you think you should apply it based on the needs of your design and your network. See you in the next.